Why are the servers being so bad today?
There was something with the portal, and it's actually I think not just Washington Township, but the I think it's just any portal server like Rapid Identity because my son goes to Crestview Elementary, which is in Lawrence Township, and they were having issues too with their portal. So I think it's on the company that does that. Um, see here. Um, and today is going to be a sort of, we're going to try this experiment here today for our project. It'll be kind of a crapshoot. We'll see if it.
Is it gonna be right now?
I'm going to wait. It'll be after we do all the beginning routines and stuff. But it's we're gonna see if we can make it work. It might just have to be a demo on my end after we try it, but I want to give everyone a chance to try it.
Can I go make me some cereal real fast?
Yes. Okay.
Okay.
In fact, speaking of that, you guys, I'll be since it's 9:49. I'll be back real quick. I'm gonna fill up my water bottle. Uh, all right, let's see here. Here we go. Admit all. All right, glad to see everybody's able to get in. I Did you guys all have issues earlier with the Rapid Identity? Yeah, I think it's Rapid Identity's fault because my son's just we live in Lawrence Township, and so my son's district they were having issues with their portal too. So I think it was Rapid Identity. Let's see
Are
here.
you at school right now?
Are we what?
Are you at school?
No, I'm at home because my son and I got tested for COVID. I'm not. I don't feel sick, but I got it just so he didn't have to do it alone because it's really unpleasant how they do it. But they, but he's been sick for the last week and a half, almost 2 weeks now, So we're waiting on those results. If the results come back negative, then I'll be back at work and he'll be at school. But we didn't want to. We couldn't send him to daycare, or we couldn't have somebody come see him since he was possibly sick with COVID. So I got the okay to work from home. But I'm actually in the room that I sort of based my homepage off of, though. This is the room I redid over quarantine, built that wall and all that, and all the other stuff in the room. All right, I think we got enough people in here that we can get rolling. You guys, bear with me today because like I said, we're going to do the project. I'm really hoping that we are able to do it, but it might be a complete crapshoot in the sense that, like, I might just have to do it as a demo, but I really want everyone to give it a shot because doing projects, actually doing them is so much more fun than not doing them. But let's see here. Vanessa's here. Christiana B, are you here? No. Jayla's here. Emery, are you here? No, Emery. Let's see here. Ismeen, are you? Yep. Orlando. No, Orlando. JD, are you here? No, I don't see JD. Madeline. No, Madeline. Jordan's here. Nevaeh's here. Jacob's here. Eric's here. Michael Jennings is here. Miles is here. Emiliano's here. Jabari, nope. I saw you did. Jabari actually did some work, but no. Demarion. Mauricio. Nope. Dylan's here. Oterio's here. Jonathan's here. Carter, not here. Leo is here. Theodore here. Jaya has never been here. And then O'Neill is here. And Mauricio. All right. So, that being said, I'll share my screen with you guys real quick. Boom, boom. Got our daily news going. Let's see here. Last slide. Okay. So students will be able to plan and problem solve a problem from the scientist perspective. Today's the 13th, and then Michael Jennings, would you be willing to read our daily news, please?
Hey, DOS kiddos. Today we are going to get prepared and identify the problem we are going to try and solve. Once we are done with our DEGs, I will review with everyone to make sure we have the proper charts to set up for today. Once we have this done, we will go through the slides on what the scientists would do to solve the problem and begin working as a scientist. I'm excited to see you guys try this at home. Thanks, Mr. DOS.
All right. Thank you, sir. Nicely read. So, like it says there, we've got our DET to start, and then we'll kind of get everything set up for the project, make sure that everybody has that chart made that you were supposed to do before leaving last class. And then we're going to kind of start the project and kind of do the portion of the project that the scientist would do. And then, so just so you know and what to anticipate through this project, we're going to do what the scientist would do to solve the problem. Okay, then we're going to do it from the technologist and mathematician, or technologist view, engineer's view, the artist's view, and the mathematician's view. So we're going to do this project and then do all the portions that each field of study would do. And so you can kind of see how they all are similar. But I'm gonna close that. So then, but in the meantime, I'll let you guys get rolling on that DET. It is day 5. Just so you guys know, next time I see you next week, we start the rotation over. So when I see you on Monday next week, it'll be back to day 1. Okay. So, but we're on day 5 right now. So click day 5, click 813. Okay. Only give you 5 minutes to do this. It's 5 questions, all quick multiple choice. So I'll set my 5-minute timer as my virtual background here. And good to go. Yeah, you guys got about 90 seconds. I'm going to step out real quick and grab one more thing I need for the project.
Mr. Doss, I forgot how to do this. I mean, I forgot these questions. Mr. Doss.
Nevaeh, you there? Sorry, kiddo. I had to step out and get one more item for the project. But
Oh, I said I forgot how to do it. I forgot what these are.
you can always try and look back, okay? Because with DETs, you're always allowed to use your notes, okay? And so if you want to go to that page and review that information, that is fine.
Okay.
Just try and be quick because of that timer. Once you open it, it doesn't pause it, even if you leave the page. All right. Are most of us done here? I'm gonna get us rolling then, because I imagine
It says I can't view it.
you can't view that page in the module.
Oh, I went to the DET thing.
Oh, yeah. So try and be quick because that timer keeps going. All right. For everybody else, though, I'm going to kind of go through this. This is a good page to kind of give an example of. So I'm actually going to share a different page with you guys. I'm going to share this with you guys. Okay, so since this page has several of those colors that the
It didn't let me finish, but okay.
I can let you go back. I'll go and get and adjust it so that you can get more time on it.
Okay.
I'll get everyone set up through this, and then I'll do that for you. So looking at this page here, okay, the first question said, what color of text means to copy and write down every word in that color in your engineering notebook? So your options are red, black, blue, and green isn't on this page, but so what, you can even kind of look at this and kind of get an idea. Which color do you think is the color that you would need to copy down? Any volunteers?
Red.
Red isn't that. Red
Blue.
tells you something else, even though red, the word, like that has the word copy in it, but it's not. If red were the color that you would need to copy every word in that color, it would ask you to you would have to write in your engineering notebook, copy the following chart. You have to write those words, because there's a color that you're supposed to literally take whatever words are in that color and put them directly into your engineering notebook. So if it's not red, what do you think it is? Oh goodness, people. We're going to talk a lot today because you guys are going to go to breakout rooms where you're required to have your cameras on and you guys are going to have to interact. And I'm going to be grading you based on collaboration and all that stuff. So you might as well start getting ready. Okay, who can tell me what?
It's not red. The only other color on there is blue.
Very good. Okay, blue. Blue is the color that if you see anything written in blue, you have to copy those words that are in blue into your engineering notebook. Okay? So eventually, when we actually start this project and get to this page, you'll have to write down scientist dash study the world and conduct experiments on it. So you'll actually have to write that stuff in your engineering notebook. Okay? Don't do it now. So blue is the answer number one. Okay, it says, what color of text represents something that you have to do? That's telling you to do something. Is it black, green, red, or blue?
Red.
Red, very good. Red is the action. So red here it's telling you to copy the following chart into your notebook if you haven't already. So, and that's why the stuff in that chart is in blue, because blue, you would copy those exact words into your chart. Red is just telling you to copy the following chart. So it's the action. Red tells you some sort of action to do. So good, okay? And then it says, what color text is the most overlooked color of text, even though you are expected to read it? Red, black, green, blue.
Black.
Black. Okay, a lot of people say, oh, this one doesn't have a color to it, because black is just the default color of the text. So I guess I can skip that. And don't do that. Don't be one of those kids, because this is just as important as this and this. Okay? Because these are the instructions. Okay? These are the instructions. While it's not an action, it's going to tell you what exactly you need to expect and do for the project. Okay? So black is there. Okay? Which type of heading do you underline in your engineering notebook? That's not going to be from this page, but does anybody remember? Is it major headings, subheadings, other stuff, or regular notes? Which type of heading do you underline?
Subheadings.
Subheadings, very good. Thank you, Yasmin. Okay, subheadings are the ones that you underline. Okay, and then which type of headings are you supposed to write in extra large font and put in a box that is 5 blocks or lines tall?
Major headings.
Major headings, thank you, Jacob. Okay, major headings. So that's how you would get a 5 out of 5 on that one. Let's see here. Nevaeh, I'm going to allow you an extra attempt, so then you should be good to try and access that again. Okay. So now, moving right along, next part of the agenda, I want to review. Let's see here. I guess I can go from here. Let's see here. Boom. I'm going to click previous. Okay. So you guys, this is where we left off. Did all of you get a chance to copy down this chart before you left class, last class? Copy this chart on a piece of paper. Did all of you guys do that, or do I need to give us time to do that? Jonathan, yes, Jordan, you may. And Jonathan said he did. Jacob, go ahead and copy that down then. Since you didn't get a chance to do that, you're just making that exact chart on a separate piece of notebook paper. And then all those who are telling me no, they didn't get or they weren't able to. Yes, Michael, you may, but all those who weren't able to, just take the time right now to copy this. To get to this page for yourself, if you go to modules and then click on the page that says STEAM Notes Chart, okay, and you can copy that chart down. Okay. If you've done that, or once you've done that, okay, you've made that chart, STEAM at the top, and then leftmost column is problem, and then you have scientist, technologist, engineer, artist, mathematician, all the parts of STEAM. Okay, so you have that chart made. Once you've had that, okay, pull this up so that you can, if you want to, follow along. And so if I go past a slide too quickly, you can go through this, because again, like I told you when we talked about how we're going to use Canvas, each unit will have a Google Slides presentation with all the slides that we go through so that you can also go through. I'm going to share my screen with the Google Slides presentation going on. But again, if I skip to the next page and you haven't finished doing what you were supposed to do from the last slide, okay, you can always go back if you pull this presentation up yourself. Okay, so so I'm gonna. Does everybody have a notebook handy?
You said a notebook what?
Like a notebook, some notebook paper handy, and their note cards and tape.
Me.
Okay, because those are kind of going to be your essential items for today. So then I am going to go ahead and move right along. Okay, so let's see here. If I'm going to not make this full screen. If I pull this up and then pull this up, new share, click this. Okay. And if I do this, okay. So what I'm going to have you do right here, okay, is on a fresh sheet of notebook paper, okay, copy down. Anywhere you see this sign copy, it means you're going to have to write something down. Okay, it's kind of like blue, but in Google Slides. But you're going to copy down this heading, and this is going to be a major heading. That's why I have it boxed right there. And then write that heading down. So have your paper, okay, large box that's 5 lines tall, says Unit 1.1, Introduction to STEAM, or STEM/STEAM, and how STEAM creates our world. Okay? So as you kind of see everybody writing right now, they're making that heading. Okay? Put it in a box. It's a major heading. Okay? Because it's the start of a new unit. It says here, Unit 1.1, Introduction to STEM, how STEAM creates our world. That looks good, Nevaeh. A little large, but that's okay. That's as long as it's bigger than everything else. I have a kid from my advisory just popped in. I'm gonna check with them, see if they're okay. Hey, Kimberly. Hey, Kimberly, are you trying to figure out where you're supposed to be? Because we're in our period 1 class now. Do you want me to look up? Do you want me to look up your period 1, or do you know where that is?
Can you look it up for me?
Yeah, sure thing, kiddo.
Can we see what that looks like?
No.
So Kimberly, let's see here. Kimberly, you're supposed to be in math with Mr. Williams.
Okay, thank
All right,
you.
see you, kiddo. No problem. See you, kiddo. Nevaeh, did you have a question?
I said, can we see what your son looks like?
What the what looks like?
Can we see what your son looks like?
Oh, my son? He is in the middle of class. There's a news story that I put on my homepage. If you want to watch that video, because they did a news story on him. When we adopted him back in January this year. You can, if you click on my family photo on the homepage, it'll take you to that.
Okay.
Everyone have that heading copied down? They're good? All right. So I'm going to go ahead next on the presentation then. So it says, how is each part of STEAM needed to solve a problem? Okay. And it says the six column chart should be copied neatly into your engineering notebook. If you haven't copied this down, do it now. Like I said, you guys should have this copied down. Okay. You should have a piece of paper that has this chart on it, where it says problem, scientist, technologist, engineer, artist, mathematician. So we are going to investigate how, if we present one problem, okay, how each of those fields or each of those parts of STEM, or STEAM, I should say, would contribute to solving that problem. Okay. So you have that down. So again, that's why it says copy. Okay. Because you're supposed to copy that chart down. So everyone should have that copied down. It should look like this again. So got that down. Okay. Then on a separate piece of paper, okay, and have it only kind of cover, you want to have it the paper sideways again, but have it only go about halfway down. Okay, or I guess you don't have to have it sideways. If you want it vertical, that's fine, but have it only go down half your page, because the other half is going to be notes that you're going to want to take. Okay, so you're going to make this chart on a separate sheet of notebook paper. Don't put it on the back of the first chart, because again, once we get our engineering notebooks, each of these pages you'll just glue or tape into your engineering notebook, so you don't have to rewrite anything. Okay, so it's going to kind of seem wasteful of paper, because you're only going to, all the paper you're going to do is just on one side, but that's just so that you don't have to keep rewriting things when we get our actual engineering notebooks. So so copy this chart. I'll give you guys some time to do that into your onto your sheet of paper, okay? Because this looks like gibberish right now, but you'll see what I mean by twofold method, equal L, half and half method, flat roll method, and then squares, triangles, and circles. So you'll just make that chart, and then, like I said, you'll see what I mean by this afterwards. And then once you are done, hold your paper up so I can see, and I can give you the thumbs up that you are good. In the sense of you copied that chart correctly. And so those with cameras off, just know you will have to turn your camera on to show me your chart. All right, hold it closer, Michael, so I can kind of see. Let's see here. Yep, that looks good. And is it half? It is only takes up half your page. The bottom half is free. Yep, you're good. All right. Looks good. You're good. Jacob, Dylan, you're good. Man, I feel old. I'm like squinting to look at your guys' stuff. You're good, Jordan. Jayla, how are you doing, kiddo? You good? I am. Miles, that looks good. You're good. Is mean good. You're good. All right, Jayla, show me real quick just your notebook paper. Theodore, you're good. Jayla, you're good. Jonathan, how about you, bud? Yep, you're good. Emiliano, how about you, kiddo? And Leo? Ontario? JD, you're good. All right. So you got, JD, you have some space on yours where you can write notes on the same page?
Mm-hmm.
Okay, good, good. Vanessa, you're good, kiddo. Mauricio, how about you, buddy? Eric, did I see yours yet? Nevaeh, show me yours then. Did you leave yourself space to write some notes too?
Yeah.
All right, cool, cool. Mauricio, you're good. All right, so Eric, Leo, Emiliano, and Ontario, you guys are the ones I'm waiting on, but I'm since most people are done, I'm gonna move along, but just know you gotta get that done at some point. So next part for us, I'm gonna click next. Okay, so our problem is the book stack. Okay, so you need it to be able to, what you build to be able to hold a lot of weight with very little materials and very little time. Okay, so, well, that's all fine and dandy what they did. I'm talking you want it to hold a lot of weight. Okay? They were not successful in holding a lot of weight. All right? So on your chart that you made last class, okay, I want you to fill in and copy this down in the section that says problem, okay, because the problem we're investigating for this project is how do we hold something very heavy with the smallest amount of material possible, okay? Because in real life, okay, oh, JD, just go ahead and this slide, this Google Slides presentation is on the module. So if you go to that, you can actually click along yourself and go back to the slide that you need to see. All right. So so it says, how do we hold something very heavy with the smallest amount of material possible? Okay, because in real life, these are construction projects. Okay. Like for example, bridges. Okay. We have to make safe bridges. Okay. They have to be able to hold tons of pounds. Okay. Huge semi trucks have to be able to cross the bridge without the bridge collapsing. But at the same time, do you guys know what pays for bridges? Or who pays for bridges? Anybody know? You guys do. Your families do. Because bridges are funded through taxes. Very good, Jonathan. So, because it's funded through taxes, any taxpayer is going to say, well, you better manage that money right. Okay, you better make that bridge, it better work, but you better not waste a bunch of material. You better not make it super expensive. You better be able to make it so that it's cost effective, but also it works. Okay, so this is a problem that in real life people have to solve, and so we're going to look at this problem from all the different perspectives. Okay, so again, we're trying to figure out how do we hold something very heavy with the smallest amount of material possible. Now we're clearly going to do it on a smaller scale. We're not going to make a massive bridge. Okay, but we are going to kind of simulate it. So then, where it says scientist, in that box, please write down that what the scientist does. Okay, a scientist studies the world and they conduct experiments on it. So a scientist is going to ask the question, which fold and shape combination is the strongest? Okay, and just so you guys can see where this presentation is lining up in your in the mod, oops, sorry. How do I make this smaller screen? Just so you can see how where this chart is lining up in your where's my it's scientists. Do you see this where it's in blue? Study the world and conduct experiments on it. Scientist studies the world, conduct experiments on it. So these slides line up with this page of the module. Okay, notice you copied this chart Says today you're going to play a role of a scientist. You'll be testing two variables for the book stack challenge: fold style and fold shape. Remember, to be a scientist, it is more than experimenting with things, it is writing it down. Okay? So all of this, okay, in your modules covered in the presentation as well. Okay? I just want you to be able to see how this lines up with the module and the Google Slides presentation. Okay? So in our simulation, that's why we're using our note cards. Okay? Because note cards aren't very heavy. They're very small, but they're going to have to hold stuff that is much heavier than themselves. So we're going to try and figure out which type of fold method with the note cards and which type of shape in the note cards, when combined, have the strongest hold. Okay? Because as scientists, that's how we're going to conduct this experiment. So it's kind of like how an ant can hold stuff that is significantly larger and heavier than itself. Okay, how again, a bridge can hold stuff that's significantly larger and heavier than itself, or giant billboards. Okay, so scientists study just that, different materials and different shapes of materials that might be the strongest. Okay, so like I said, for this part, you'll get to kind of role play a bit. And today we're going to be scientists. But it's all going to come back to, so the S in STEAM stands for science. Okay, I include these kind of funny GIFs and memes. So I like the one on the left particularly because it is really like actually true. Okay, because being a scientist, you get to just kind of screw around and do really cool things you find interesting. But the only difference between screwing around and science is that you actually have to write it down, data track, all of that stuff. It's just a little bit more formal. And then, does any of my 8th graders, I want to see how good your 7th grade science teachers were. 8th graders, could any of you guys explain how Neil deGrasse Tyson can do that, where he has that bowling ball and he lets go and it comes back right where he let go? Does anyone know the explanation of that one? This is just me going off on a tangent here because I used to teach 7th grade science and physics was my favorite unit. Anybody?
We didn't get taught this.
You guys didn't get taught physics?
We didn't get taught this right here, what he's doing.
Like, did you learn like the 3 laws of motion?
Nope.
Oh my God. Who was your science teacher?
Mr. Newson.
Oh my gosh. Mr. Newson is the one who
Nope.
took, Mr. Newson's the one that's in my room, and I am going to have to talk to him about not doing my room justice. Man, physics was my favorite. We used to sumo wrestle. We used to do tug of war. We did all sorts of fun stuff. But all right. So it's for every action, there's an equal and opposite reaction. That's why that works. It's never going to come back. It'll come back right where you let go, because it'll never come back with more force. All right. So Again, so the S is going to be what we explored today. You're going to work with some groups. Now, this was, like I said, this project was created with the idea that we were going to be back in person, but we're going to make do with it as best we can. So, so we're going to have 3 different groups, okay? And one group is going to do one fold method, another group's going to do another fold method, and then the third group is going to do the last fold method. And then in each of those groups, we're going to try different shapes. Okay, so how many people, just by a show of hands, how many people actually were able to get their hands on some note cards and some tape? Yeah, so I got, how many? I got 1, 2, 3, 4, 5. Anybody else? 6 maybe. All right, so I'm going to try and make sure that we at least have these people in, like, divided up between the 3 groups. I'm going to make a breakout room. And so what you guys are going to do, each group, like I said, is going to build a different shape so we can test which one is the strongest. And then the shapes you're going to test are going to be circle, equal L, square, and triangle. And so the 4 shapes. So this is what. So you guys know what a triangle, square, and circle looks like. Okay, equal L is just that. Okay, it's going to be like almost like it's like half a square or an unconnected triangle there. Okay, where it's half vertical, half horizontal there. So the so you can see that. Let's see here. So all right. So I want you in your. I'm going to break you guys up into these 3 groups, and then I'm going to assign you a fold method. Okay. And so and then and so I want you on your notebook paper. Okay, like I said, I want you to only have that on the paper where you had the chart with the different fold methods and shapes. Then I said leave half your paper kind of with some space to take notes. I want you to copy the diagram of the fold method that I end up assigning you guys. Okay, so one group is going to be assigned the 2-fold method. Okay, one group is going to be assigned the half and half again method, and one group's going to be assigned the flat roll method. Okay, and if you got a ruler handy, great. If not,
be doing this right now.
well, I haven't assigned you guys yet a group. So once I assign you a group, I will go into each group and tell you guys which fold method you guys are going to be experimenting on. Okay, sound good? We'll probably only get into our groups, and then and from there copy down the diagram for the fold method we're assigned, and then that will probably be as far as we go. We won't get to actually test our folds until next class. Okay, so let me go from here. So I'm going to make 3 breakout rooms and randomly assign people, but I'm going to each breakout room just sit tight until I visit your breakout room and tell you guys which folding method your group's going to be assigned to do. Okay. So let's see here. How do I? If I go here, go to breakout room. Okay. assign people automatically to 3 different rooms. I'm gonna create those rooms. I'm opening all those rooms. Now let's see here. Okay, go ahead, hop into those breakout rooms. All right, we got all 6 people here. 1, 2, 3, 4, 5, 6. Yep. Okay, cool. So you guys, I'm going to assign you guys the two-fold method. Okay. So you guys on that sheet with the chart underneath it, just copy this diagram that shows you how to fold your note card using the two-fold method. I'm going to demonstrate it to you. Okay. And those who, and you're going to fold the note card, not your paper.
Can we use a piece of paper because I don't have a note card?
For the sake of getting, I mean, you can try that, but if you use paper, we're not going to count that towards our data collection because it's a different material, so it'll skew the data some. Okay. So who in here has note cards? So I make sure we at least have some people. So I got 2 people in here. Eric, do you have a note card? No? Okay. So the 2 of you might have to split up some of the shapes. There are 4 shapes, so each of you can do 2 different shapes. But you have to make those shapes all with doing the two-fold method initially. What that means is for the two-fold method, if you look at the note card, it says your first fold is like hamburger style. So you would go like this.
Are we gonna go into the next class with this because class ends
Yeah,
in
class
5
is
minutes.
almost since class is almost done, I'm just gonna get you guys set up, and then we'll probably just have to actually conduct and collect the data and conduct the experiment next class. So so you fold it like this, and then you do it. It says hot dog style for your second fold. Okay, and then once you have it like this, you're gonna shape it into whatever the shape is that you're gonna have to make. So like if it's the equal L, you would just like kind of fold it in half again, but then have it set like that. Okay. Or if it's a triangle, you'd have to make that folded into a triangle where it has 3 sides. Does that make sense? So since Michael and Miles, you guys are the ones with the note cards, everyone needs to copy down that diagram in there on that piece of notebook paper by the chart. Okay. And then those 2 of you, Michael's, you're going to use 2 note cards, make them both the two-fold method, but you can choose 2 shapes and Miles can choose 2 shapes. Okay. Sound good? Because I'm going to go to the other rooms now. So how do I leave room? Leave room. Hey kiddos, everyone turn your cameras on right now, just so I can kind of see everyone in here. Because you guys are also going to talk to each other a bit. So can you guys see, just so I know, like, can you guys see that you guys are in breakout room 2, or does it say breakout room 2 for you guys? Or does it say anything?
Yes, it does.
It does? Okay, so that's good to know for the future. So then what I can do for my other classes is tell them, if you're in room 1, you do this, room 2, you do this. So, all right, so since you guys are room 2, you guys are going to do the half and half again fold method. And so what I'm going to have everyone do is, regardless of if you have note cards or not, you guys need to copy this diagram that shows how to fold your note card. Okay, I'm going to show you real quick in my camera what this means. So that first image of the note card, and it has the number 1, it shows you to take your note card, fold it in half hamburger style, like this. So it's like this, and then you're going to fold it in half again. That's why it's half and then half again method. And so you're going to have a long, skinny little piece like this. Okay? And so you copy this diagram in your notebook because you're documenting, okay, your procedure for folding your note card. So everyone's going to do that. And then who are my note card people in here who actually have the note card? I've got Vanessa.
I have no cards.
Jayla, okay. Ismeen, okay. Do I have a 4th by chance? Did we get lucky in here? All right, so you guys divide up. One of you is going to have to do 2 shapes, so use 2 note cards, but you use this, you use the half and half again method, and then you take what you have and then fold it into whatever the shape is. So if I would add the equal L, I would fold it again so that then I could have it looking like this. Or if I had a circle, I would roll it and so it looked like this. But your first 2 folds have to be those, and then after that you make your shape. Does that make sense? So you guys talk amongst yourselves, say who's gonna, since those who have the note cards, who's gonna make what shape. There are 4 shapes that you guys have to make, so one of you guys with note cards is gonna have to do 2. Sound good? But this will be the last thing that we do. Just figure out who's who, and then I will bring everyone back from the break rooms once I've talked to everybody, and then dismiss you. But don't leave until I've dismissed everybody. Sound good? All right. I'm going to go to the other room then. Hey, Oterio, rejoin your breakout room because I'm going to visit your guys' breakout room now, okay? I just have to talk to the first 2. All right. Breakout rooms, join 3. Where'd everyone go? Did people leave? Dang it. Well, thank you guys for sticking around. Who are the other people who left so I can make sure I know that they're in your group? You're not ratting them out for leaving. But do you guys know I want to know so I can, when we rejoin this next class, so Leo was also with you. And then anybody else? Leo, and there should have been 3 other people, right? Or 2 other people after Leo. I'll try and figure it out. Thank you, though. All right. So what you guys are going to do, and if you guys could have your cameras on just so I can kind of see you guys and explain. So who all in here was able to get their hands on some note cards? Anybody in here? Theodore, you were able to? You were able to, Jonathan? There's not Ontario, and that's okay. So Jonathan and Theodore, what you'll end up having to do is, since there are 4 shapes, you'll each have to like make 2 of them, okay? But your guys' fold method is the flat roll method, okay? And using a ruler. And so it doesn't have to be exact. If you don't have a ruler, I'm not gonna hold that against you guys at all. Because your fold is the only one that sort of like requires any sort of measurement. So what you're gonna do, if you look at that diagram, it kind of shows you each fold that you're supposed to make. And so for the flat roll method, you take your note card, okay, and then you fold it 1 inch over, okay, and then let's see here if I can. This is kind of hard to do. Okay, oh, there we go. And then you roll it again over itself 1 inch, and then again 1 inch, and then a final time 1 inch. Okay, so if you notice that, okay, there are, it's showing you that in that diagram. What I want for you guys to do before you guys leave, okay, we're not going to actually do the experiment yet because I don't want us to have to rush through it. We can just do that next class. But on that page where you made the chart that had the different shapes and the different fold methods, okay, underneath it, since I said only have it take a page or half a page, okay, draw the diagram that shows you how to fold with the flat roll method, okay, and title it that flat roll method. The because oh, Jordan too, okay. Because with that, then I am going to have you guys, that's sort of your documentation, because you guys have to document stuff in your engineering notebook, everything you guys do. So just have that. Once you've done that and copied that down, I am giving you guys permission to leave the meeting. I just want to make sure real quick. So I got Leo, Jordan, Jonathan, Ontario, Theodore, and we're trying to figure out who that 6th person was, but that's okay. So does everyone kind of understand what you're doing? All you're doing is copying down that diagram of how to fold it right underneath the chart that you made, because then we'll collect the data next class. Capiche? Caposh. Okay, I'm going to leave you guys up, and like I said, you guys, once you guys have that diagram drawn in your notebooks, you guys can leave class. Oh yeah. Okay, Emil. You guys, I am copying everyone down in here who's in this group. So Ismeen, O'Neill, Jacob, JD, Jayla, Vanessa. All right. So you guys, if you copied down the diagram for your fold method and figured out who's gonna make what shape between those who have note cards, you guys have my permission to leave the meeting, and you guys are good. We will collect the data and conduct the experiment next class. Sound good? All right. See you guys. Thank you. Thank you. All right, kiddos. So if you guys have your diagrams drawn underneath your charts of like how to fold, then you guys, once I get everyone's names written down, so in this group it's Nevaeh, Emiliano,
Medea, Miles, Michael, and Eric.
Michael, Eric. Was there a sixth person though in here that left? Who was that? So I can just remember who's in this group.
I don't know.
You can't remember? Who was it? I'll try and figure out who it was. But the if you guys have that copy down, you guys are good. We will conduct the experiment and collect the data next class. But we are all prepped and ready to go for that, so we should be good. So thanks, guys. See ya.
Mr. Doss,
Yep, Jonathan.
what time is our next class?
Your next class starts at I believe what 11:20 because this class went from 9:50 to 10:50, and then office hours are technically from 10:50 to 11:10. So this class technically has 10 more minutes, but if you have everything done that you need to get done, then you are good. So, all right. So Yasmin and Vanessa, are we all good?
Yeah, I guess.
You guess? Oh, that's not reassuring. Yasmin, which group were you in?
Yeah.
Or you were in group 2? Okay. All you guys needed to do, just so that you know what you were supposed to get done today, is copy the diagram of your fold method onto that page that has the data chart or the data table.
Okay. Is
Okay.
it like on the Google, is it on the slides?
Oh, can you not see my screen share? Maybe when we did breakout rooms.
Yeah, it got off.
Okay, here, I can share it with you right now. It is on that Google slide presentation. Like everything that's in my presentation is on that Google Slides
Okay.
thing at the beginning of the unit. But if you want to copy that down. So you were in group 2, so weren't you the half and half again method?
Mhm. I mean, I guess me and Vanessa, like, she's gonna do. Wait, Vanessa, what were you gonna do?
I'm gonna do triangles and squares, I think.
Yeah, and so, but you both, the fold method before you make your triangles is that you guys are half and half again method. And so, so you have to do your initial folds like it shows there on the chart. And then after that, you'll like, so as me, so that's you, so you're doing equal L. So for your initial folds is mean you'll take your note card, you fold it in half once, fold it in half again, and then with this, with it shaped like this, you're going to now fold it into whatever shape. Excuse me. Oh my gosh, that was embarrassing.
Like the square and the
Square,
circle.
yeah. So then you fold it into
Oh.
square, or does that make sense?
So that's okay.
Yeah, okay.
Yeah, and so just have that, and then set that aside, have it ready to go. We're not going to actually collect any data and do the experiment yet. Because I don't want it to be rushed. So I just told everyone, if you copy down that diagram underneath your chart and then actually just tried to fold yourself, then you're good, and we'll actually try and put the weights on it.
So it'll be like kind of like this and put tape
Yeah.
on it.
Yep, that'd be a circle. You would tape it, and then you would kind of use that as like and then you'll eventually end up like stacking books or whatever you have that kind of weighs a lot at home to try and see how much weight it can hold.
Okay.
Sound good?
Yeah.
Yeah.
I guess it sounds easy.
Yeah, it's not too complicated. Sometimes I know that the diagrams are a little confusing to try and follow. Like,
I guess it would be a little bit more fun and like easier if we were in school.
yeah, if we were in school, you guys would have tables and like it'd almost be like a competition of like, and we would all have the same. It would like this data isn't going to actually be real data because you're going to have to use something for weight that no one else has. The book, like if we were at school, we would use the same types of books and stack them and stack them and stack them, kind of like you saw in that picture. They were all the same books, and so it's easy to track how much it weighs if you know the weight of one book, and then if 10 books were stacked on it, you know, whatever the weight is times 10 is the weight. And so it's going to kind of be, but I want you guys to at least feel like you're doing it, just because it's no fun to just watch me do stuff and talk all day.
Yeah.
So,
And Mr. Goss, you've been saying my name wrong the whole entire time.
oh my God, correct me. How do I pronounce it?
It is.
You literally just cut out right when you said your name. What is it? I can't hear you. Oh no, I can't hear you. What is it?
It is Minnie.
Is Minnie?
Yeah.
Oh my God, I am so sorry, kiddo.
Don't worry, you're not the only teacher who says my name wrong.
I know, but it's your name, and I want my kids to know that like I respect them and appreciate them, and then like that starts by taking the time to get kids' names right. So I'm so sorry.
Yeah,
Call
I've been
me
trying
out
to correct the teachers.
every time I say it wrong, unmute yourself and call me out, even if it's in front of the whole class. Okay. I'm not gonna get mad because I need to get that right for you. Okay.
It's fine. I'm used to it now.
Oh my gosh. All right. So is Minnie, right?
It's Minnie.
Knee. Like, okay. Is
It's
Minnie,
like Minnie.
Minnie?
Yeah.
Mini me? Like a mini minion? So is Minnie.
Yeah, that's it.
Is Minnie? Okay. Okay. All righty. Well, I will work on that. So thank you for correcting me.
Bye,
Okay.
Mr. God.
I'll see you, kiddo. Take
Have a
care.
nice day.
You too. Bye.